Architeuthis.
Hi, I'm Guy Cope of Architeuthis, and welcome to Machine Learning Mondays, the series where I break down basic machine learning concepts, knock the edges off buzzwords, and try to make ML accessible to all y'all. For today's topics, supervised models. Supervised models are the most common type of machine learning, and they power most transaction monitoring systems. Even systems that implement other types of machine learning models will typically still use supervised models in some capacity. In supervised learning, there are many different kinds of models, but all of them can be categorized into two types: classification and regression. Both kinds of supervised models use a concept called features, data points that have some kind of significance as determined by a team of data scientists, data analysts, and subject matter experts. Subject matter experts such as your compliance officers or fraud investigators. In classification, this team will assign data to certain classes, categories of behavior, or different things that have a definite "this is what it is" category. For instance, you could have activity classified with two features, fraud and not fraud. In regression, the model is trying to determine how features relate to one another and find their trend over a time period. Some variables are dependent upon other variables, where other variables might be independent. Dependent means that another variable that occurs has an effect on that, whereas independent variables exist on their own and may not have an effect on anything else. For instance, instead of fraud and not fraud, you might have a variable that's fraud that is dependent, and it is dependent upon the independent variable increased spending at a mall kiosk. This means that the model would then look to see if fraud increases or decreases as spending increases at a mall kiosk. A simpler way to look at it is this. A classifier will try to tell you if something is good or bad. A regression model will try to tell you if certain activity makes good or bad things more likely. In financial crimes compliance, both are frequently used. So how does the supervised model figure out how things are good or bad? To understand, let's take a look at the life cycle of a model. The first step in the creation of a supervised model is to analyze your data, to know what the data you should use and what type of model or models will work best. Do we use classification or regression? Is there a certain type of classification or regression model that would work best? What data do we consider important? What features are there? And you do this using the team we talked about before, data scientists and data analysts working together with subject matter experts to understand what actual connections matter and what connections found in the data are just noise. The team will then build the first version of the model, and that is when it's ready to begin ingesting the data that you've chosen and analyzed already. When it comes down to the model ingesting data, think of it like feeding a baby. The baby doesn't necessarily know what it needs to eat or even what it is eating. Instead, the baby relies on its caregivers to make it the right choices for its health. For the model, it relies on the data scientists and subject matter experts, like compliance officers, to make those choices. The choice of data for the model should be based on what you want the model to do. For instance, models in fraud, sanctions, and KYC might all ingest some of the same data: names, addresses, dates of birth. However, a fraud model is going to need transactions and chargebacks. Sanctions may need sign-in locations, while KYC probably needs signals from a data broker, like Axiom or Ideology. Now that we've selected the data and selected the model based on what it is we want the model to do and the data we believe supports that, it's time to train the model. And this is done by creating labels. And these labels will determine what's good and what's bad. And who trains the model? You do. Or at least your compliance officers, investigators, and other humans who use the software and work the outputs of the system. The model will create an alert, which is an output, for the investigator to review. The investigator will then make a decision, and that decision will go back to the model. In general, the investigator will mark the label for the alert true or false in the system. If the investigator labels the alert false, and other investigators do the same, the model will learn not to generate that kind of alert. If the investigator labels the alert true, the model will learn to generate more of that kind of alert. The more alerts reviewed, the more decisions made, and the more labels created, the faster and better the model will learn and improve. Essentially, you're taking the machine and having it act more and more like your human decision makers. So why use supervised machine learning in your financial crimes compliance program? Why not just use rules or other things with definite outcomes? Well, the first reason you should consider supervised machine learning is its simplicity. Compared to other machine learning models and even some more complex rule systems, supervised models are much less complex and therefore easier to explain. That can make it much easier to defend a supervised model to people without a machine learning or technical background. The reason for this is that supervised models have defined outputs, meaning that you can tell what data went in, you can understand to a certain degree why certain data made certain decisions, and the fact that humans are in the loop means that humans are actually having an effect on the model outcomes. All in all, this leads to a relatively simple system, especially in the machine learning space, that you can explain to just about anyone. The second reason is accuracy. Supervised models are far more accurate than other types of machine learning because humans train them. So long as the humans who make the decisions are reasonably accurate themselves, the supervised models will also be accurate. This means much lower false positives than rule-based systems and higher quality false positives. Essentially, you'll catch more bad guys and have to sift through fewer good guys to find them. And because this is a machine, even though humans could eventually come to these decisions one at a time, it can do this at a bulk level. Instead of processing 1 or 100 alerts, it can process thousands or 1,000,000 alerts. That means that you have a very accurate system over a large amount of data. The third reason is validation. And this is where compliance and financial crimes can be a little different than standard machine learning. In compliance, you're going to have examinations. You're going to have regulators who want you to defend the decisions that you've made. And in other spaces, it may just be that you need to make sure things work correctly. But when you're dealing with people who are independent of you, who are going to make a conscious choice about how well your system is working, validation and the ability to prove that the system is working matters a lot more. And supervised models are easier to validate from a compliance perspective than other machine learning types. The alerts created by supervised models come from clear product features, features that you decided were important, so that you can actually say, this is why it works this way. And supervised models usually score their features in some form or fashion, which means that you can have that displayed somewhere, whether in documentation or in some kind of a system, which then makes it easy for you to show that the model and what your investigators in turn consider important. All this makes it easy to see if the models and the investigator disagree as well. This kind of thing becomes very important when you're making an attestation that your program is working for something like New York 504, and this can make the difference between you being able to confidently state, yes, I have a good system, and yes, it's working reasonably, and going, I'm not really sure how that works. So validation in the compliance space is a very important aspect, and supervised models are pretty easy to validate. At this point, you might be thinking, supervised learning seems perfect. It does everything I want it to do, and it does it better than rules and traditional systems. Let's implement it everywhere. There's no downsides. Well, not quite. One of the biggest issues with supervised models is that they take a lot of time to hit peak effectiveness. If you put a rule in place, you start getting outputs from the rule immediately, and you will always know exactly what you're going to get. But because supervised models rely on humans' input to train, that means the model needs a lot of labeled data. This can easily take 6 months to a year of working with the model. The smaller your organization, the longer it will take. There are ways to offset this problem. One of the best ways to combat this is for multiple companies to train the same model. This way you can get a lot more data and a lot more data together. And this is pretty common in cloud-based and big data systems. something else we'll discuss later on Machine Learning Mondays. Another issue in supervised learning is noise. This can occur if a model trains too much on the exact same data or becomes too complex for the data it uses. That means that it got many more product features or more data, and those product features aren't actually helpful, might actually be duplicates of others, or the data you're sending is actually not good enough, or perhaps it is too detailed. All of this could mean that the model won't respond to new or unseen data, and essentially it'll stop learning, meaning that it's not improving anymore and in fact might be getting worse and worse. This defeats the entire purpose of the supervised model. Now you just have a very fancy, very expensive rule system that actually works a little worse than rules. To prevent this, a certain amount of training data, the data that your investigators are working on, should be used for testing. If the result has little to no errors at all, it's probably time to give the model some new data or to take a look at those product features and see if there's some that are working in tandem. Essentially, two product features that are equally important on the exact same data, meaning that it's causing you to essentially double count certain things. That means it's time to take a look at those features, take a look at that data, and begin training again. The last issue we'll address is both the greatest strength of supervised learning and one of its biggest weaknesses, and that's the human factor. Supervised models rely on humans to work. They need humans to create label data and create features. And when training a model, let's say you have a procedure that has something wrong, and that causes all of your investigators, your humans, to keep making the same mistake over and over again. That means the model will be trained to make that same mistake too. So when creating features as well, biases and assumptions can cause teams to create the wrong features. And this can lead to false positives, overly complex models, which can cause them to start learning, or completely irrelevant outcomes that don't work. Or this can lead to places where you have outcomes that fit the expectations of the people using it, but might not actually be the right ones. So that makes it very important to have an independent validation of your models to make sure that they are working as expected and they're working as they were designed to work. This can really go in and find biases, make sure that there isn't too much noise in the model, or if there's certain outcomes you're looking for, that your humans aren't making the same mistake. So when you have an independent validation done, you should make sure that the procedures used to work the model are also included in the validation. In closing, let's make this simple. Supervised models are designed to learn by example. They are taught how to perform by the people who use them. And in the financial crimes compliance space, investigators and compliance officers are typically the people training them. Over time, the model will begin to perform more and more like the people who train it. And this is normally a good thing, but repeated systemic mistakes by the humans using it will cause the supervised model to eventually make those mistakes too, which makes validation of the supervised model extremely important. In the end, the pros of supervised modeling greatly outweigh the cons in this space. They're more accurate than rules-based systems, they respond to new trends and new activity more quickly, and are relatively easy to validate, making examination defense simpler. I hope today's session was helpful to you. If you enjoyed the video, please like the video, leave a comment, and subscribe to our channel. And if you have more machine learning questions, and I suspect you do, Architeuthis has you covered. Thank you for watching.
Thank you for watching. Please like, subscribe, and leave a comment.